Ladies and gents, welcome back to another Engineers podcast. Today I'm joined by Fabio. Fabio is a senior data scientist at BlaBlaCar, and they're your favorite carpooling company. They're headquartered in Paris, and essentially they want to be the go to marketplace for ride hailing or ride sharing. They're going to be talking about some really interesting stuff today and how they've used ML and built some really interesting algorithms to ride hail, essentially. And we're going to break that down into a couple of different components. Fabio, how are we doing?
It's pretty good. Thanks a lot, Elliot. Thanks for having me. It's a pleasure. And yep, happy to talk about BlaBlaCar and what we do.
Love it. We always start with the person. So, intro Fabio, the guy, his career, and some of his background, and let's get to know you a little bit better.
Yes. So name is Fabio, Fabio Cecchi. I'm from Italy, as you can guess from the accent, I guess. My background is in mathematics. I studied in Pisa, in Tuscany. It's a pretty nice place to study in. It's full of students, and the university is pretty cool. Uh, After that, I moved to the Netherlands for my PhD. It was still in mathematics, but moving towards the applied side. So, stochastic operational research was the main topic, applied to wireless communication networks. After that, it was time to make a decision what to do, keep remaining in academia or moving to industry. My wife, she remained in academia, so it was a easy decision to move out and avoid the two body problems in academia. That it's always difficult to find a place for both. And luckily, she went to Stanford in California. I followed, and well, it's not a bad place to start a career in data science. Uh, and I joined Bosch.
Okay.
Bosch is a German company. It's very old, but they have a research center for artificial intelligence in California. And you can imagine that as being a kind of a consulting company within the company. So whenever you have a business unit that had a cool idea about applying AI to uh, hmm, a tool they were producing, they were coming to us and asking for proof of concepts, POCs. So it was a great learning opportunity to see many different things. Uh, I enjoyed that a lot, and then was the time to come back to Europe. And what I missed there was the impact on a product. So going to having seeing what your algorithms are doing live, and that's when I joined BlaBlaCar. I knew the company. It's a pretty cool one. The mission is interesting. It calls for mm, it tries to be environmental um, to be complying with the environmental needs that we have at the moment. And the goal is actually to have zero empty seats on the road, so as to have all the cars that are actually going to be on the road anyway, because drivers have to ride. Help them find the matching passengers to join them in the ride, and help them save some money on the way.
It's a pretty competitive landscape, though, right? There's a couple of big names in that space.
It is, but it's also so if you compare us with Uber, for instance, or other ride-sharing companies, we are not targeting the same segment. So our drivers are really non-professional. We don't want to have more cars on the road due to BlaBlaCar. We just want to help those that have to drive anyway to avoid doing them by themselves and share the cost with other people and have them save some money that they would not be able to recover anyway other ways.
The tech for good angle. I love it. I love it. Um, you said you wanted to go back to an environment that you can actually see the impact of your work. And I think there is probably no better product than working on something that is real time, that has an impact on your customers literally instantaneously. Your feedback loop is instant. So that is something that we're going to be talking about today. The ML powered algorithm that you've written a blog about. We can almost like dissect that blog in a little bit more detail. And for everyone listening, that's below here in the description. But let's talk about that ML powered algorithm. What is it? Its purpose within BlaBlaCar. Why did you build it? How did you build it? There are a few questions there, but let's break it down.
Yes, and perhaps before doing that, let me introduce a bit how BlaBlaCar works, because it's otherwise might be complicated to follow. But what we do actually, we have two types of. Mm, I'm focusing on the carpooling part of BlaBlaCar. There are others like we can buy bus tickets or mm, soon trains, but that's really not the focus of this podcast. So let's focus more on the carpool side. That's our art. In carpool, you have two actors. You have passengers and you have drivers. So what the drivers do, they publish the trip. So they go to the platform. They say, I want to go from Milan to Rome. Uh, let's say in 3 days from now, leaving at this time and arriving there very likely around this hour through this itinerary. After you publish that, that trip ends up being in our inventory, and so that we can pull it and show it to potential passengers. So the other side is the passenger. What they do is they make a search. They want to go from Milan to Rome in 3 days from now. Can you help me? And then we just show all the eligible match we can find in our inventory. They see the price that was set by the driver. They decide whether to do a request or not. There is a lot of social component as well, so they can see who the driver is, their bio, why do they want to do the trip. A lot of time you have very interesting matches, and you end up having interesting conversation in the car. But it's in that part is where the passenger decides what to do, and try to ask the driver whether he would accept them as passengers.
It's actually a really interesting business concept.
It's very very interesting. It fits very well into this sharing economy where you have something that is your car, and you're willing to drive, and you have to make the ride anyway, and you just want to see whether someone is interested into that. You might help some persons in need, or you might actually just save some money and get some get some extra inputs for you.
Yeah, okay. I I reached out to you obviously because I wanted to explore this further, but I've always been really impressed from what I've seen externally with regards to BlaBlaCar, and that's probably got to be now for the last 6, 7 years. So I think that's really kudos to how the business has grown, and you have grown geographically as well. You are headquartered in Paris, but it'd be good to talk about that business growth and how it's expanded geographically, because that was something that you were mentioning in your blog as well.
Yes, absolutely. And at the moment, BlaBlaCar is spread into 22 countries. Uh, we cover most of Europe, but other places that are extremely different in terms of, let's say, transportation profile, like Brazil, Mexico, India, Turkey, and it's it's very interesting to see how different places behave differently with respect to carpooling. In Europe, we have France and Spain are our the countries where we are the most developed, and that's also due to the public transportation profile that happens in different countries. If I think about Italy, in Italy, it's trains are very cheap. It's very easy to go from A to B with a train. Other places might not be as lucky, and we feel a void that is mm, in a way that is actually not too environmentally damaging.
Yeah, okay. It's a really interesting market segment. It's very specific and a really interesting market segment. So let's get onto some of the tech stuff. Um, the ML powered algorithm. Let's let's break that down. How does that actually work inside of BlaBlaCar's platform?
Yes, the algorithm I will talk about is called smart selection. And smart selection is actually what we do. At the moment, the passenger make a search. What we do is we decide whether we to display or not some of the results that are eligible. So to give you an example, let's keep with the driver going from Milan to Rome. Um, what we do, we in order to increase the chances of that driver to be successful, what we do is that we create what we call uh, boost rides, and those are some rides that the driver doesn't have the intention to make, but anyway will be along the way. So imagine you have a passenger that instead of going from Milan to Rome wants to go from Florence to Rome. So that's let's say midway. So be picked up. I'll say half of around half of the trip, and a drop at the end of the trip. Um, what we do is we, in principle, will show that that option to the passenger making a search, and in case that passenger mm, like the trip and make a request, the driver receive what this boost request, asking asking him whether they'd be interested in making a detour. If they are, then the new trip is created, the trip is adjourned, and now instead of going from Milan to Rome, you go from Milan to Florence to Rome. So everything it's kind of artificial. So we are creating fictitious rides and just probing the driver to see whether they'd be willing to make it. However, the not all these boost rides are the same, and what we developed is a machine learning algorithm that is trying to predict whether a ride we create would be accepted by the driver. If it is, if we believe that it will be accepted with a high probability, we keep showing that ride to the passenger. If we instead we believe, yeah, there is no chance the driver would accept, then why show it in the first place? So we just decide, yeah, let's hide it. Let's not show it in principle, and hope the passenger will find something else.
Inside of the algorithm, so are you predicting that the driver is going to say yes to the ride?
Correct.
And how does that work?
So we are a very data-driven company. We collect data, we store data about our inventory, and how drivers in the past reacted to request they received. And that's a perfect setup for a supervised machine learning algorithm, where you have your own set of data. That's kind of uh, the features representing a ride, and you have your label that is the driver has accepted that a request for that ride or not. And with all those ingredients is it's fairly intuitive how a machine learning model could come into play. We have XGBoost, so tree-based model, fairly simple, fairly small, but quite robust. And the interesting part is that we also get insights about what makes a ride interesting in general. So imagine that, still same example. So Milan to Rome, and the driver asked for 40 euros. Then the boost ride we want to suggest has a detour of 15 minutes and will bring the driver 10 euros. So 10 euros out of 40, not too much. I mean, would really a driver be willing to stop in a place that they don't know to pick up someone and get only 10 euros for that? So the idea would be, in that case, probably let's not show that. And another example is it really depends on whether the request would come close to the departure or far away. So what we see is that when the request for a detour arrive very far away, drivers might not be likely to accept it because they still hope to be able to find passengers that are willing to do exactly the same trip they do. Then there is this probability increase mm, as the departure time arrives, because they get scared that they don't get a passenger willing to do what they want. And then it drops because they don't want to do any last minute kind of change in their schedule. So all these insights are very interesting because we can show them to product, to business, and convince them that actually what we do makes sense, and they should. And it helps building their trust and their confidence.
You talk about amassing all of this data and how important it is to your business, and the more companies that I talk to, especially on A/B testing, which we're going to go into, you've got a really nice concept, ABC continuous probing, and we spoke a little bit about it there. But talk to me about that journey where the business have actually started amassing all of this data to be able to make the algorithm what it is today. Like, what does that actually look like for a company? Because we're talking about so many intricacies here. We're talking about so many nuances here about the driver's behavior, the passenger's behavior, that takes time, that takes volumes of rides in the business that you're in. Like, when does that journey actually start of how you
Yeah,
amass data, collecting it, storing it? Because that's driving what you're doing today.
true. It doesn't. So it's not a switch. It's not a on-off switch where you say, "Okay, from today I'll be a data-driven company." It actually started way before I joined. I joined the BlaBlaCar only 2 years and a half ago. The company was founded in 2006. We have data about our supply from, let's say, roughly 6, 7, 8 years ago. Um, it's it's an evolution in a certain sense because the company invested a lot into building a team that could reliably collect data, massage them, put them into such a form, such a shape that could be useful by data scientists as well as business analysts, data analysts. Mm, what I could mention perhaps is that over the past few years, the data team grew a lot. So we, at the moment, we are close to 50. for a company of 800 persons, that's a reasonable amount. And we work with a data mesh format in which we have pillars with that represents a bit our business units, where you have data engineers, data scientists, data analysts, and software engineers. Um, and for instance, I am in the data carpool supply squad, so we care about indeed the inventory of our carpool. But there is also the data operated bus, data pro supply, so professional marketplace. It's and each of those silos is independent, and they are autonomous in they own their data, so they are the go-to persons for what's in there. The same way, so you have these vertical grids, and then you have the horizontal layers where you have the skill sets. So, for instance, we have the chapters of data scientist, the chapter of data analyst. So that basically you have exchanges with your peers with that might not work with the same data you do, but they might help you with the technologies you actually have to master.
Got you. Okay. Let's touch on the ABC continuous probing, because we've spoken about some of those behaviors and how the algorithm actually does it, but let's put that into practice. Are you able to give us a use case? Are you able to actually explain the concept and how you do it?
All right. So where I would start. So before going to ABC, let me start from AB. It's what we imagine. You are a team, and you want to. You are telling your stakeholder that you are going to hide some results from the search page. They are going to ask why. Why are you doing that? I mean, that's just limiting our chances of creating matches. What we thought as a team was that actually by hiding some of the bad results, we would reroute some of the demand from our passengers towards better options, and therefore actually increase the chances of finding a good match for them. But yeah, one thing is being having an opinion. Another is trying that in practice. And what we do, we ran an A/B test. It was now 2 years ago almost. And that was the first time we tried to hide some results in France. We ran a test for 1 week just to observe how passengers react differently and whether they could find matches more or less easily with by hiding or not. And we actually found out that it was not just bringing better performance in terms of acceptance rate, so the probability that the driver were going to accept the request, but also at the end of the day we were generating more matches. So that was a very good KPI to monitor for our stakeholders. The problem of A/B test is that it gives you one point in time. I mean, it tells you that in the month of October in France, in that week, hiding 20% of results was better than not hiding anything. But what is the best fraction of rights to hide? That's not a question that is easily solvable with an A/B test. And at the same time, it's a question that might have an answer right now, but in 1 month, that percentage might change. So what we did, we designed this ABC continuous probing, where what we do is actually we lose a bit in terms of optimization. So what we do is split our passengers into different groups. So we have 3 groups of 30% passengers each, let's say. I'll talk later about the other 10%. But these 3 groups, for let's say, for one group, we hide 20% of the results. For one, we hide 30%, and the other 40%. And every week we observe how the KPI of interest behave for these three groups. So if you take 1 week in isolation, that's not a significant test. So we are not claiming that we are statistically significant according to anything theoretically sound. But we are fine with making some mistakes. So if at the end of the week we see that the 50% group behaves better than 40 and 30%, we switch the groups and we add a bit more. So instead of 30, 40, 50, we add 40, 50, 60. So and we are fine indeed with making mistakes from time to time. We believe that over time we are right more than wrong,
Really?
and then we potentially revert back if there are mistakes.
I'm really interested in the segmentation part of the people or the data that you're analyzing. Is that segmented for any particular reasons, or is it classed in a certain way? It'd be good to understand that, or if it's just totally random.
So it is totally random. At the same time, though, we there are segments of users that are more interesting than others for us. We are a business. We want people to come to our platform, keep coming to our platform. Therefore, let's say our top drivers, top passengers, so the one that do the most trips, of course, we look at them a bit more carefully, so we don't want to damage them too much. And the other very interesting segments are the newbies, so the one that come to the platform for the first time, and imagine you try something new, you want to be successful immediately. So you want to, if you are a driver, you want to find a passenger immediately. If you are a passenger, you want to find a driver immediately. And if you don't, for actually you might never come back. And for us, it's a big missed opportunity. So we give we are fine with losing um, some percentage of the main KPIs we look at if we can favor the success of some of these specific segments.
Got you. Okay. What are you doing that's quite clever around monitoring, reporting, and dashboarding to drive some of these decisions?
Yeah. So we invested quite a lot of time in having reporting dashboards refreshed, some daily, most of them weekly, to make them accessible and readable by not just by our team, so the one actioning the algorithm, but also by our stakeholders, so that they could see and look at our performance over time. Uh, Actually, that was fairly interesting because having them looking at those dashboard brought a different set of eyes uh, into them. And one example is that I think it was 6 months ago, more or less, they observed that for some drivers, we were actually not doing as well as others. And those were the drivers that were publishing trips that were very unpopular. So imagine you want to go from a rural town to another rural town. No passenger will want to make the same trip as you do. So if we start hiding boost rides along the way, so potentially from rural to rural, you actually pass from two big cities. Most of your passengers will come from this intermediate segment, but we are hiding those because we are not making discrimination whether where you come where what is your actual departure arrival point. and they observed that for them actually we were damaging their chances of success more than for others, and they just pointed it out. And then the interesting part was that as the data scientists, we were able to try to understand why that was happening, whether we could change something. And the idea there was to add some features to the algorithm, because it's very interesting. Because our drivers, they know how popular their trips are. So if they go rural to rural, they know they have to accept what's in between. So adding those information about where you come and where you go to was able to make the algorithm to predict the driver acceptance much more accurate, and we could bring back up the success rate for that segment of drivers as well.
Okay. Thinking about this, this might sound like a dim question, but I'm thinking about this for other B2C products. You're basing your theories on data, and consumer behavior can be very tricky to decipher and understand why people are doing things or why people don't do things in this instance. Are there ever opportunities to communicate directly with customers and ask them why? Like, why did you not want to do this? Or
Hmm.
would
Hmm.
you be able to give us some answers? Because
Yeah.
we've got the data, but we actually need your brain here to
Hmm.
like help us understand it, because that might be able to help companies building products like this for a large scale customer base understand what their consumers are doing.
Absolutely. Where to start? Okay, so for instance, yes, we communicate with our base. Uh, Actually, a lot of our customers, our users, they are very keen to give feedback. I mean, they love it, and it's so they can raise tickets, they can communicate with us, they can, and it's very interesting to observe what they think, and how they believe we should do things. Um, that's Our user base is also very diverse, so finding a unique algorithm that would accommodate everyone, very unlikely. But it's we definitely can do better. um, One interesting thing is we try to imagine you're a driver, you receive a request for a boost ride, so including a detour. uh, what we ask you basically is, are you going to accept it or not? If not, we try to get feedback from you. So there is a form, there is a multi-choice uh, answer that you can give. Unfortunately, that's a very dirty data, because it's very easy to keep the uh, form empty, and the multi-selected choice not moving that. But it's something, and for instance, it helped us adjusting a bit the way in which we were selecting the detour radius. So dropping that from, let's say, 15 minutes to 12, or this kind of stuff, because
Okay.
due to feedback from our user base.
Okay. What advice have you got for people running machine learning algorithms in production? General advice or do's and don'ts?
It's, first thing, it's a long journey, so it's very easy to try things. Meaning, doing an A/B test with something in prod, uh, that's almost too simple. If you have the right support, meaning software engineer that could help you, and it's so in that case, no big problem. But that's just the beginning, because after that, how do you maintain your machine learning algorithm? How are you sure that the data you're feeding to the live in prod hasn't drifted from how the model was trained? That part requires a lot of effort, a lot of resources. There are there is some standardization that is coming into play here with all the MLOps frameworks that have been developed that are getting easier and easier to use. But there is a cost for starting it from scratch, and you need the right resources. So software engineers are fundamental in this. Another thing is in order to have guaranteed the right amount of resources and the right amount of capacity in your time schedule to work on this, you need to have a great relationship with your stakeholders. So you need to have their trust, so that if you tell them, look, for the next 2 weeks, next month, I will not bring you anything new. I just need to standardize this tool or make this more robust. They need to be fine with that, and so that you can reliably keep evolving your tools.
Okay, that's a good bit of advice. It's a good bit of advice. Okay, before we wrap up, what should we expect to see from BlaBlaCar in 2024? What big, grandiose plans are coming?
Okay. So BlaBlaCar is at the art is a carpool company. It wants to be a multimodal source for transportation. So the goal of BlaBlaCar is actually to sell not just carpool, but bus, train, combination of trips. So imagine you have a bus going from where you are to close to your end point, and for the last piece, you add a carpool that brings you close to home. That's super challenging. It's and what makes the company extremely cool, because the challenges that are pushed to us keep changing, and yeah, so it's a very cool company to be in.
Love that. Let's see. Let's wait and see where you guys are up to, and we'll be checking in at some point. 2025, time's flying, but 2025 we'll be checking in and see what's evolved. I
Looking
want to say a
forward.
massive thanks for breaking down machine learning algorithms in production. It's been a while since we've really focused on something like that, and um, ironically, the last company that we spoke to about that was in a really similar industry in Spain. Um, but a big thank you to you, Fabio, for coming to share some of your insights, your do's and don'ts, but breaking down the algorithm itself and explaining that to our subscribers.
Thanks a lot. It was a pleasure, and yeah, waiting for you in 2025, and let's see where we are.
Yeah, exactly. Um, for everyone else, likes, shares, subscribes, they're massively appreciated. And they obviously contribute towards continuing our community. For all the links that we mentioned below, they're going to be there below, excuse me. And from all of us at Engineers, it's a big thank you, and bye for now.
Thanks.
Hey guys, thanks for watching this episode. Massively appreciate you listening and checking in with us. If you want to find out more about us and what we're doing, please check us out on social media. What we're trying to do at Engineers is build a community to drive knowledge sharing and experiences. On Twitter, we can be found engineers.io. It's no underscore. We've also got a website which is engineers.io. These links will all be posted in the description. Any feedback and comments are massively appreciated. We're always looking to improve on where we can. Thanks, guys.